Well, some of the ways the university is preparing students to enter the 21st century agricultural production, and really any form of technology and infrastructure development, is that we take students and we put them into situations where they can see and use agricultural opportunities. We see opportunities for agricultural production that integrate these concepts. For instance, I work in agricultural production of algae biofuels, and we're now growing algae in large volumes in very low-cost systems that agriculture would embrace. The team that you have out here kind of helping us this morning clean is a broad spectrum of research, young scientists who are trying to understand how we can produce algae economically and at the scale that would allow us to replace, say, 50% of our fuel oil. This program is really built on the backs of these graduate students. Most of them have a variety of different programs that they work under. Saeed there is kind of our algae growing expert right now. He's learned how to manage the algae and grow it in these large culture situations. We've got a couple students out there that look at contaminants that sneak in and try to take over, and they're trying to understand how that happens. We've got a couple that look at the oil content that are out there. I've got a couple of mechanics that build this stuff that you see around here. It requires novel thinking and ingenuity to build something that's never been built before. So this shack here represents the brains and the control of the entire operation. What you see there is a Campbell Scientific controller, and it has inputs out in the raceway that look at dissolved oxygen levels and gives us an idea on how healthy the algae is, and temperature and water flow, and the pH we control by adding carbon dioxide. And so this is a completely automated system. That's our goal, in that it can turn on itself in the morning, put in the nutrients it needs, add the carbon dioxide, and grow the algae all day long. And at the end of the day, the computer can determine if there's enough algae present, and it can move it into our harvesting system and start the harvesting process. And eventually this whole farming operation will be run off of a centralized computer system with our underground piping system and our above ground water delivery system. Computer program will decide how much water is needed in the soil based on a parameter, maybe an ion reading unit that detects how much water there is in the soil down to 6 or 8 feet. And then we'll make important decisions on how much nutrients to add in, as well as how much water. The computers, you can put down seed in your planting within an inch of where your seed bed should be, which minimizes the use of land and maximizes productivity per land unit. One of my favorite little projects that we put this in before we had electricity present at the Red Rock Ag Center, and it's been running continuously for 5 years now, producing electricity with really no cost. It's a really amazing system. It runs off of 3 simple panels, and the well is about 600 feet deep, but we place the pump at about 300 feet, and we pump 6 gallons per minute all day the sun's shining. And it's really been a reliable system. It was really easy to install. I actually installed it myself, and being a molecular biologist, I'm not that great with tools, but I really think this is the future of agricultural production, with especially for a domestic water system.